Welcome to the percent composition lesson today. So what we're going to be doing is we're going to pretend we are finding a sample and we're running it through a machine called the mass spectrometer and finding some results on kind of the proportions of each type of element that are in the compound. Okay, so again, we looked at this back in Unit 1. If we were trying to measure like we were trying to measure the different types of isotopes in that unit. So we would put it through a machine here, and it's based on the mass of the different isotopes. So when they went through, it would hit the detector at different spots because of the mass when it goes through the magnet here and curves around. So that's how they would identify the different isotopes. So we're doing the same thing here, but we have a sample, and we're going to figure out, say, it's going to be able to detect how much carbon, how much hydrogen, oxygen that is in the compound. So then we're going to take those results and figure out just like the percentage of, the elements in the whole compound compared to the overall compound, the overall mass, okay? So in this example here, we're looking at, we know we have some sort of carbon, hydrogen, oxygen compound. We don't know exactly how much carbon, hydrogen, and oxygen there is in the compound, but we ran it through a mass spectrometer and we found these results. So in the first sample that they put through the machine, they used 2 grams, and they found the results came back as 0.8 of carbon, 0.16 of hydrogen, and 1.0-ish of oxygen. Okay, so then they did the another sample, but they used more. They used 4 grams, and they found these results here. And then they did another run where it was a 6-gram sample, and they got these results here. So we're going to figure out the percent composition of each sample here, okay? So if you're wondering what percent composition is, think of it like if you, your test is out of 100 and you get 80 of the questions right. So you got 80% correct, okay? So it's the same idea here. So if you have a certain amount of sample, like 6 grams, and you found that, of the 6 grams, 2.4 was carbon, then you can find the percentage of the 6 gram that was carbon. So it's like whenever you calculate percentage on your test, you take what you got over the total, and then you multiply by 100. So same idea here with percent composition. So we're trying to figure out the percentage of the element in the compound. We're going to take the mass of the element divided by the mass of the sample and multiply by 100. So in this case here, we're taking the first sample here and trying to figure out the percentage of carbon in this mass of 2 grams here. So when we did that, we're going to take the mass of carbon divided by the total mass of 2 grams and then multiply by 100, and we get 40%. So of this 2 gram sample, 40% of it is made of carbon. Okay, so we're going to go through and repeat with all the other measurements here, and this is what we get. So in a 2 gram sample of this carbon, hydrogen, oxygen compound, we will get 40% carbon, 8.4% hydrogen, 51.5% oxygen. Okay, and again, these results are from like the machine, and then so we went to 4 grams, and we were finding, oh look, it's the same. Okay, so it doesn't matter how much of the sample we put into the machine, we're finding that it's always coming out to the same percentage of the different elements. Okay, so that leads us to our percent composition equation. So if you look on the back of your on your formula sheet, okay, so right here, this is where your percent composition formula is. So if you ever need to quickly look it up and so forth. So if I'm trying to find the percentage of an element in a compound, I'm always going to take the mass of that element and then divide by the total mass. Okay, multiply by 100. And then we'll get to percent yield a little bit later in this unit. But it's the same idea. Okay, So you're going to be using this formula a lot today, and just keep in mind that I know we've been working in grams per mass. It doesn't always have to be that case today. As long as you have the same units here, it's like you're finding a ratio of the units. So as long as they're the same, you can just rule them in. So if I have, I don't know, milligrams or kilograms, or as long as they're both the same, it'll still come out to the same result. So just keep that in mind. All right, so that moves us to the law of definite proportions. Okay, so elements in a compound are always present in the same proportion by mass. So if you're looking at like you saw back in the analysis here, it didn't matter what mass that we added into our analysis, we ended up with the same percentage of all the different elements. Okay, so here we're showing you, okay, well, what if we took like actual molecules of water? So if I take one molecule of water, we always have 2 hydrogens and 1 oxygen in a molecule of water. So even if I take, 8 molecules of water, 1, 2, 3, 4, 8, there's 8 stacked up here. Even if I take 8, but in the end, it's a 2-to-1 ratio for the hydrogen oxygen. So it doesn't matter if the mass changes, there's still the same proportion in the end, okay? All right, so we're going to move to an example here, okay? So yeah, just law of definite proportions, make sure you know that. All right, so here's the first one. So we have some aspirin here, and it's saying, okay, so we have a 500 milligram tablet. So we have this one tablet of medicine here, and we did an analysis in the machine, and we found that there's 300 milligrams of carbon, 8.08 milligrams of hydrogen. Okay, the rest of it, of the mass, is oxygen. So from there, can you determine the percent composition of aspirin? So it's like kind of a vague question, like I guess what they want you to do, but you have to understand that when I ask you to find percent composition, I want you to find the percentage of every element that's in this compound. So we have 3 things here. We have carbon, hydrogen, and oxygen. So you need to go and find all 3 things. Okay, so I'm going to use graphs here again. So this way we organize kind of the information that we have and what it is that we have to find. So okay, so we have the mass of aspirin here. Okay, we have the mass of carbon. And we have the mass of hydrogen. Okay, so, and then you could figure out the mass of oxygen as well. You could just take your 500 and subtract carbon and hydrogen. And, there'll be another way to kind of figure out the percent composition later as well, but we can just calculate this out right now. And let's write down what we need to find next. So for now, 1.9192 milligrams is the mass of oxygen. I think it says the remaining mass is oxygen. All right, so what we need to find here is we need to find the percent composition of carbon, the percent composition of hydrogen, okay, and the percent composition of oxygen. So again, so you get familiar with the terminology, we need to find the percentage composition of aspirin. Okay, so what that translates to is literally percent composition of carbon, hydrogen, percent composition, and percent composition of oxygen. Okay, so these are all the things that we don't know that we want to find. Okay, all right, so what's our plan here? Well, we have an equation that we just learned about. So I'll use the one that's on the back of your formula sheet. So percentage of x, whatever that is you take the mass of x and you divide the mass of the total of the sample that's involved, and then multiply by 100%. Okay? All right, so let's go through and actually write the work now. So I'm going to start with carbon first. Okay, so I want to find the percent composition of carbon in a sample of aspirin here. So I'm going to take the mass of carbon, which is 300 milligrams, and I'm going to divide by the mass of the total sample. Okay, and then multiply by 100. Okay, so just don't actually multiply by the percentage, just go times 100. Okay, so you end up with 60%. Okay, all right, let's try the next one, hydrogen. Okay, so we had a mass of 8.08 milligrams, and we still have a total of 500 milligrams. Okay, and then multiply that by 100. And we end up with, and don't forget to multiply by 100. Sometimes I have students, they forget, and they leave it in the decimal form. Okay, so then you get to there, and then the last one is you need to find oxygen. So we calculated the mass up here by subtracting, the total from carbon and with hydrogen and carbon to get the mass of oxygen. You could, so you can use that mass there. And then, just do the usual here. Oops, should have been 92, sorry. Okay, and then you get 38.38%. Okay, so you could do it that way. Or back here, you could have gone, well, I know the, I know like the total percent, right, is 100. So if you already had 60 and 1.61, you can take those and subtract them. And you get the percentage of oxygen as well. So that's just another way to calculate out the last one. If you know the remaining mass has to be that element. Okay, so then here I just get 38.38%. Okay, so that's the total. That would have been this is the mass of the carbon, and this is the mass of the hydrogen. Okay, so that's how you get the mass of or the percent composition of the oxygen. So that's just another way to do it as well. Okay, all right, so from here, make a therefore statement of what you found. So again, I want you to use the key words here. So what did you find, or what did they want you to find here? They wanted you to determine the percent composition of aspirin. So again, that's the key word that you want to write down first. So the percent composition, percentage composition, okay, is, so you're going to say 60% carbon, 1.616% hydrogen, and 38.38% oxygen. Okay, like that. So just again, concentrate on what's the thing that you have to find. State that in your statement, because a lot of you are not writing in your keyword. You're just saying kind of essentially the answer is this. So I need to know what it is that you are finding. So just make sure, look for that keyword and write it in your final statement. All right, so hopefully that was okay. It was just literally like if you got, if the test had 500 questions, you got 300 right. You got 8 right. You got 191 right. So what percentage did you get on your test? these are the percentages. So that's how you can think of it. So we took a sample, we ran it through the machine, and the machine told us, well, there's this much of carbon, this much of hydrogen, this much of oxygen. So you're saying out of the whole tablet there, 60% is made up of oxygen, 1.6% is made up of hydrogen, and the remaining 38% is made up of oxygen. And so that's what you're finding today with percent composition. You're just telling me the percentage of the element in a sample. Okay, so if it ever says determine the percent composition, find and make a statement for everything that you see here. Okay. Okay, on to the next example. For this example here, this is the other type of question that you'll see. It's a little bit more vague. It doesn't give you any a lot of information, so you have to kind of dig out your molar mass information. Okay. All right. So I want to know the percent composition of calcium hydroxide. So think of it like, okay, well, we don't know like how much of the sample we have. We don't know the total mass and so forth. But I just want to know in general if you had, like one molecule of calcium or compound of calcium hydroxide in that compound, what percentage by mass is calcium, oxygen, and hydrogen. So you can do this, make this comparison by just going in and finding the molar mass of the whole thing and then the molar mass of each individual element. Okay, so we're going to do that right now. So I don't know, you could think of it as like what's given to you. Well, you can find the molar mass. So I'm going to, again, just to remind you, I'm going to use capital M for molar mass. Okay, so we're going to go and find the whole compound here first. So the molar mass of calcium hydroxide. Okay, so again, to find that, I hopefully you guys can see that there's one calcium. So see how this 2 is on the outside of the bracket. So that means there's 2 oxygens and there's 2 hydrogens. Okay, so you're going to take your calcium. So you go to your periodic table, and like here, go to your periodic table. Oops. Go to your periodic table, and here is calcium right there. So you're taking that mass, hydrogen and oxygen. Okay, and you're gonna tell me the molar mass. So 1 calcium puts forth 40.08 grams per mole. 2 oxygens, 16, and 2 hydrogens, 1.01. Okay, and then calculate this out. Again, please don't round these values. Carry all the digits. And then you get 74.10. So I know your calculator will round the 0 up, but just know that there should be a couple digits there after the decimal point. All right, so that's the molar mass of the whole compound, okay? So, I don't know, you could think of it as the whole compound here. So now, I just want you to find the masses of all the individual elements, okay? So, so when you're looking at the formula calcium hydroxide here, in that formula, you know that there's 1 calcium. Okay, so there that one is, okay? And then from there, now we're gonna just look at just the oxygens. So you know there's 2 oxygens. And that came out to 32. Okay, and then, so we'll just separate them here. So it's essentially what you did there, right? And then there's 2 hydrogens. Okay, so we now know the element masses, and we know the whole compound mass. So I want you to think of this as being the total. Okay, so if you're looking at your formula from the other side, so you think of this as like being your mass of the total. Okay, and this is your mass of X. Okay, the sample. So what is it that you have to find here? You need to find the percent composition of calcium hydroxide. So that means literally I want you to find the calcium. I want you to find oxygen and the hydrogen composition. Okay, so I want you to tell me what percentage of calcium hydroxide, what percentage is calcium, what percentage is oxygen, what percentage is hydrogen. Okay, so again, you're going to use, this is your plan here, you're going to use the percent composition equation. Okay, so the mass of the element involved and the mass of the total, okay, times 100%. Okay, so this one's not too bad of a question. It's just sometimes people will get to this one and go, oh, there's no information here. There's no mass. How can I do this question? So you have to remember, okay, well, you can still compare the molar masses of the different parts of the compound, okay? All right, so let's start with calcium. Calcium. So if we're looking at in the compound of calcium hydroxide, calcium makes up 40.08, okay, grams per mole. Okay, so, and the total though of the whole compound is 71.0 times 100. Okay, so again, it doesn't matter what units you have here, as long as they are the same at the top and the bottom. Okay, and 40.08. So then you get 54.09%. Okay, so just a reminder, make sure you're multiplied by 100, but not by 100%. Okay, so literally you just bring the percent unit down with it. All right, so there's calcium. Let's quickly go find oxygen and hydrogen. Okay, so I went ahead and calculated the oxygen and the hydrogen. So again, oxygen was 32 compared to a total of 74. Okay, so 43%. And hydrogen was 2.02 grams per mole compared to 74.1. And then it makes up 2%, 2.7%. Okay, so let's make our final statement here. So again, it said find the percent composition. So use that keyword, therefore the percent composition. I'm okay if you write percent composition or percentage composition. Okay, of calcium hydroxide is, so we had 54.09% calcium, 43.18% oxygen, and 2.73% hydrogen. Okay, so that's all you're doing today. You're just telling me what part, like of a total mass of 74.10, what percentage of that mass is made up of just the calcium atoms and oxygen and hydrogen. Okay, so that's what we're finding here today. So after those two examples, if you feel pretty confident, you're like, oh, okay, I get this, this is easy, you can go ahead and go work on the practice questions and the checkpoint. Otherwise, I have a couple more here that are similar to the other two examples, that just if you need to see another example just to kind of solidify everything, okay? Okay, so example 3, researchers isolated a compound containing some nitrogen and oxygen. They found the 4.6 gram sample of this compound contained 1.4 grams of nitrogen. Find the percent composition of this compound. Okay, so again, that last sentence there, hopefully you understand that. It means find all of the different elements that are in this compound, okay, the percent composition. So it says here that it's a nitrogen and a oxygen compound, and we know so let's write down all the information we have here. So we know that we have a total mass of 4.6 grams. Okay, and we know that the mass of the nitrogen is 1.4, and the other element is oxygen. So in order to find that, just subtract 4.6 and 1.4. And you get 3.2 grams. So we know the mass of oxygen, okay? All right, so our goal here is to find the percent composition of both of the elements, okay? So it doesn't actually say go and find nitrogen, go and find oxygen. You should just know when it says go find the percent composition of this compound, find the percentage of all the elements in the compound, okay? All right, and again, we have our formula here that we're going to use, but again, if you don't like this formula, hopefully you understand that you're just taking, you know, the mass of the sample and dividing it by the total. So it's like what you got on your test divided by the total marks on the test, okay? And then reporting it as a percentage. All right, so there's our plan. That's the formula that we're going to use. Okay, so let's go and find nitrogen first. Doesn't matter which one. So, all right, so I'm double checking that the masses of the units are the same. So they're both in grams. That's good. Okay, and take those, calculate that out, and you get 30.43%. Okay. All right, and let's go find oxygen. Okay, so oxygen, there's a greater amount of oxygen in the compound. So there's 0.2 grams over the total mass of 4.6. And we get a mass of 69.57, okay, or not a mass, a percentage, okay? So, so in this compound, this nitrogen-oxygen compound, there is a greater amount of oxygen compared to nitrogen. All right, so let's make a therefore statement here. So therefore, again, the key word is the percentage composition. Okay, and I'm okay if you write percent composition of, we didn't know what this compound was, so percent composition of the compound, okay, is 30.43% nitrogen and 69.57% oxygen. All right, so again, to get full marks, make sure your keyword is there. All right, one more, just if you just needed to see the extra examples. Again, the other one is where there's no numbers given to you, so what do? Don't panic, just base it all on if we know the molar mass of the whole thing. If we just look at the molar mass of the different elements, what percentage can we find, okay? All right, so again here, I'll just write compound and element mass breakdowns, okay? So for the molar mass of sodium sulfate, okay, so we have 2 sodiums, we have 1 sulfur, and we have 4 oxygens. Okay, so again, you don't need to write all this down. You can just kind of go through and crunch the numbers, but if it helps you kind of organize your thinking, then do it. All right, so sodium here, we have 22.99, so 2 times 22.99. All right, and sulfur, we have 32.07. And 4 oxygens, 4 times 16. All right, so let's get our total molar mass here. So we get 142.05 grams per mole. Okay, so there's that. Now let's look at the elements separately. So in the sodium sulfate compound, there are 2 sodiums in the compound. So you're just taking what you had over on the side there, and you're just calculating the individual mass here, of just the element that makes up that compound. Okay, so there's sodium. Okay, we have 1 sulfur, so that's this 32. Oops, 7. And 4 oxygens, so that's 64. Okay, and as usual, please don't round up. Okay, just kind of carry all those digits and use those numbers because we want to always have the most accurate answer in the end. Okay. All right, so percentage composition. So we need to know the percentage of sodium, the percentage of sulfur, and the percentage of oxygen. Okay, so sodium. So we have 142. Oops. I guess I need the formula here. Okay, so it's the 8-step, the plan. Okay, so we need the percent of X is the mass of X times 100. Okay, and I'll just do one and then I'll stop the video and just wrote the other ones down, so it goes a little quicker here. Okay, so again, sodium contributes 45.98 grams per mole out of the total 142.05 grams per mole. So what percentage does that work out to? .37%. All right, so there's sodium. Okay, all right, so I'll stop the video, get the other ones down. Okay, so I went ahead and calculated sulfur. So 32 over the 0.07 over the total ends up being a 22.58 percentage. Oxygen contributes, so 64 divided by that contributes 45%. Okay, so the percentage composition of sodium sulfate. So again, if you have 142.05 grams per mole to put forward as a total, each element, what does it contribute to that total? Well, sodium contributes 32, so sulfur is 23-ish, and oxygen's 45%, okay? So that's what you're doing today, and making a therefore statement, the keyword, the percentage composition of sodium sulfate is 32.37% sodium, sulfur, and oxygen, like that. Okay, so make sure to write that out. All right, so hopefully you feel confident now and go and practice and yeah, and then do the checkpoint.